So I'm Julien. This is going to be a little trip down memory lane. I'm going to talk about past 10 years of building open source projects, and in particular open source standards. So I structured this in 3 chapters, starting with talking about Parquet, and then Arrow, and then more recently about OpenLineage. And then each of them I'm going to talk about 3 lessons learned about how open source community works, how you can define standards in open source, and how that all works. So this is what you're going to see. So first, let's talk about the birth of Parquet. And a little bit before that, so 15 years ago, I was at Yahoo back in the day using Apache Pig. So I don't know if you're familiar with Apache Pig. Who's used Apache Pig in the past? Not, oh yeah, there's some people. That was nice. So, you know, it's a bit on the downward trajectory. It's been replaced by Spark mostly for what it was doing. And so at the time I was using Pig as a better MapReduce, right? Instead of writing XML workflows to orchestrate MapReduce jobs, we'd use Pig, which was much better. And I started contributing to it, became a committer. That was my first committership on an Apache project. And that's also connecting me with the wider open source community around it, which included Twitter and the Twitter infrastructure team. And that's how I got my next job. And so working on Pig, you know, I got to all the levels of moving from contributor to Pig to committer to PMC member and being the PMC chair for a year as we were rotating that role. And so going through all the steps and all the experience of what it is to run an Apache project. So it was a very good experience for me in learning all of this. And also around the same time, that's when the Dremel paper came up and I first read it. You know, it's kind of part of good data engineering and like keeping up to date of what the competition is doing. And so then I was at Twitter, right? And so that kind of triggered the birth of Parquet of what we had at Twitter. So on one end, we had Hadoop that could store a lot of data. You know, it's kind of store a lot of machines at it, store a lot of data. Having high throughput, you can process a lot of data, but it's also high latency, right? So you would start your job, you would go get coffee and wait for the result. So you could process a lot of data, but it was not particularly fast. On the other hand, we had Vertica, when the MPP, massively multi-parallel database, and where you can have interactive queries, it's SQL, it's faster, but it doesn't scale as much, you cannot store as much data, it's more expensive, and there was always this chicken and egg problem like, oh, can we put the data in Vertica, but we can only put the most valuable data. How do we know it's valuable? Well, we know because we use it, but we can't use it until we put it in there, right? So it's kind of always that friction. So basically, it came down to how we make Hadoop more like Vertica, right? So on one end, you have Hadoop, which has 2 big components, the MapReduce processing on top of a distributed file system, right? So you have these things that's really good at scanning and doing a shuffle across the network and then writing back. On the other hand, you have the design of Vertica, which has a columnar storage underneath for efficient data retrieval and making it a lot faster to get the right data, and a distributed query engine on top, right, that can execute SQL and not just MapReduce. So how do we learn from Vertica and to make Hadoop more like this, right? Like Hadoop would have more primitives here. So at Twitter, we had this nice paper reading group, right? We would meet every week and we kind of shared of papers that were interesting. There's lots of papers that go around, but how do you, as an engineer, you know, you can't really read all of them. So how do we pick the few that are interesting and maybe some of us read it and share what they found? So we did a lot of reading about, there's some research paper around Vertica, C-Store, how it was built, why. There's a Dremel paper, there's a MonetDB paper that was also seminal in the vectorization, what are column stores, why do we need vectorization and all of that stuff. So thinking about this architecture and you know how some of it can trickle down to Hadoop and making it less, you know, like this blunt tool to process data into something a little more subtle that can benefit of the learning of Vertica. So one of the key things, right, is the columnar layout. And that's one of the key design in Parquet. That's what it provides, a columnar layout. So when you do a row layout, you just put each row one after the other one. And so you interleave data of different types. And if your column A is a string, column B is an integer, C is a date, you're going to interleave different type and they go one after the other. And it's assuming you're kind of reading all the data every row one at a time. In the column layout, you put all the data for a given column together, right? So in the end, when you store on disk, it's a linear storage. So you have this two-dimensional table, but it needs to be stored in one way, right? So in column layout, you put all the data for a given column together, which gives you everything of the same type. And it's more homogeneous storage, so you have lots of opportunity to encode it. If it's certain integers that fit in a certain range, you can maybe go do bit packing or other techniques. You have a string, and there's lots of repetition. You can do dictionary encoding. So there's lots of opportunity to do cheap, simple transformation that will compress it better. And also, when you retrieve data, let's say you're doing a SQL and you're selecting only a subset of the columns, it's a lot faster to retrieve them because it's a lot more efficient for skipping the data you don't need, right? So you're reading only the columns that you care about. So those are some of the benefits and why columnar storage was invented, because it's a lot more efficient to retrieve the data. So there was this discussion. So how do we start making Hadoop more like Vertica? One step is to make the storage more columnar, make data retrieval more efficient. And so this Red Elm project came as looking at the intersection of a bunch of existing file formats, RC files, T files, CIF, Trevny, that were existing, that kind of hinted at looking at this, but were not like true columnar state-of-the-art implementation yet. The schema systems we're using at Twitter with Thrift and the Pig project, and like the findings in the Dremel paper. And in the Dremel paper, you have two main things. One is the columnar representation of nested data structure, and the other is a query engine on top of it. And so that's how started this Dremel project, this Red Elm project, sorry, in August 2012. And I kind of following this paper reading exercise, as I started implementing the algorithm in the Dremel paper and the bus ride to and from work. So that was my side project. And the first commit, so I just dug up to know when this happened. So it's a little bit more than 10 years now. We're a bit, that's the second time I give that talk. Sorry about that. It was quite ambitious because if you notice, Red Elm is an anagram of Dremel. So the idea was to build everything. But we kind of rescoped the project after a bit and then to kind of something more reasonable. And at Twitter, all projects were named after birds. But I guess Red Elm is a tree and birds live in trees. So that was kind of a good alternative to change a bit from that. And so really looking at this, I knew I didn't want to re-implement all of this on my own. That was not quite doable. And also living in this open source ecosystem, you don't want to reinvent a storage layer and have to implement it with everything. You don't really want to build proprietary things like this. You want it to be open source. You want to find partners. You want to be part of the ecosystem so that we all work together on this. And it's actually doable, right? It's not just this giant endeavor of re-implementing Dremel from the Twitter infra team. So that was kind of my tongue-in-cheek way of reaching out on Twitter and finding people. And the reason I know there's an error in the figure 5 in the Dremel paper is because I used that as an example for my unit test, and my unit tests were not passing. I was like, I have a bug, and no, there's a bug in the paper. So that was a fun find. And so that's how I connected with the Impala team at Cloudera. Because of course, we were looking at, okay, like, how do we make Hadoop more efficient, and less of a blunt tool? And we're not the only ones looking at that, right? So the Cloudera team, the Impala team at Cloudera, was working on this columnar format. And they had a prototype, I had a prototype, and we just joined efforts. So on my end, I was looking more on the JVM ecosystem. You know, Hadoop was very much in the JVM ecosystem, integration with Pig, MapReduce, or like building nested data structure. On their end, they were focusing on building a native code implementation, SQL and Hadoop thing, distributed query engine, native code generation with LLM, sorry, LLVM, sorry, mixing my acronyms here. And so we merged designs, and that was great because on my end, I was bringing all the interoperability with the JVM ecosystem. On their end, they were building an actual query engine on top of that, so that fit the design to make sure the design of the format was going to be good for building a efficient query engine on top of it, and that became Parquet, right? We needed to, okay, now it's not, we're not re-implementing Red Elm, we're building this file format. So Parquet seemed to be a good analogy for the bottom layer of the thing. So that's what it became. And so from that, you know, looking a little bit at the timeline, we started from the first commit in 2012, then we worked together with Cloudera, and then we did an announcement in 2013. This entered the Apache incubator the next year. Along the way, there are a bunch of adoptions. Spark SQL was an adopter of Parquet when they built Spark SQL on top of Spark. They needed a columnar store as well. And so this became a good collaboration. Apache Drill was also an early adopter. Netflix implemented Parquet support in Presto that came out of Facebook that same year. And then all the way to the graduation, you know, in 2015, becoming a top-level project, collaboration with Wes McKinney, who worked on the C++ implementation when he was at Cloudera at the time. And then, you know, if we fast forward now, every major warehouse supports Parquet. It's kind of everywhere. So it's kind of magic at the time. So we put all the effort to make it happen, but it's still mind-blowing that, you know, Parquet became the de facto standard for storing data in a lot of cases. So lesson learned from this. So when you're growing this project, right, it's important every contributors become a stakeholder, right? If you want to grow the ecosystem, if you want people to keep contributing, if you want to be the project bigger than just what you can do on your shuttle ride to and back to work, when people become a contributor to the project, they own a piece of it, right? They're not just like contributing code and moving on. Now you take responsibility, you own part of it. We're building this together, right? Like, and it's been really important in building Parquet to have co-conspirators, right? Like with Wes McKinney and Ryan Blue and a lot of others, Todd Lipcon, Nongli, a lot of them from Cloudera or Netflix or other companies, and really building this together, right? So it's a strong part of it. They're not just contributing to your project. They become stakeholders, they become part of it, and they own a piece of it. And you know, with great power comes great responsibility. So I think that's one of the key factors. How you grow the project, well, you share ownership is an important part. And there's a real snowball effect, right? Like often people say, oh, it's like, you want this to be adopted everywhere. It's like boiling the ocean or you know, it's like moving mountains is just like, it seems undoable. But there's a real momentum happening, right? At the beginning, you push a small thing. You're not trying to boil the ocean. You just do a little bit. And then it keeps momentum of its own, right? The more momentum it gets, the more it goes faster, and there's a real acceleration factor. And that's the thing that you don't have to carry all that weight on your own, right? It just gets momentum on its own, and you just need to push it enough that it benefits from this ecosystem. The last part that I wanted to talk quickly about in this first phase is understanding about what open source means, right? Because you hear people talking about open source, people have lots of opinions about what open source means, and the most basic definition of it is that you can read the code. The code is available. But by default, that gives you no right to do anything with it. So the first thing you look for is what the open source license like. And in there, there's lots of licenses. So the Apache license or the MIT licenses or those type of licenses are permissive licenses. Basically, they say you can do whatever you want with it. You cannot hold us accountable if something breaks because you use it. And the only constraint is you cannot pretend you wrote it. You need to give credit. And if you change it, you need to call it something else, right? And you say, oh, it's derived from this project. And then there are other licenses that are less permissive, like GPL. Basically, if you build anything on top of it, it also needs to be GPL. It also needs to be open source. So kind of force people, if you benefit from open source, then you have to give what you build on top of it, which is very different constraint. And then governance, you can have an open source license and still you don't know how to contribute or take ownership in the project, or maybe you cannot, right? It's owned by a company and it's fine. You just need to be aware of it, right? What's the governance like? So if it's something you can become a maintainer of or not, and it's just you're only ever going to be a contributor if you're not part of this organization that owns the project. And the last thing is foundations, like the Linux Foundation or the Apache Foundation, who ensure that nobody owns a project. I mean, the foundation does. But nobody is going to control it. It's going to stay neutral. And I think for those type of standard project, like Parquet, Arrow, OpenLineage, it's really important to be part of a foundation. And it's a testament that it's always going to stay neutral. Like everybody is going to be on an equal footing in the project. So going a bit on Arrow, as part of this discussion about building this columnar storage format, right, like the bottom layer of the columnar store, that it came in the same community that we needed an in-memory store on top of it, like for different reasons, right? That comes more from the vectorization, MongoDB, how you make a vectorized query engine. So we also needed a standard in-memory format. And that's because modern processors don't just execute instructions sequentially. There's a pipeline where they kind of predict what the next instruction is going to be, and the memory cache is also very important when you need to keep the data in cache to be efficient, because you lose a lot of performance every time you need to copy data from the main memory into the processor cache. So all those reasons makes columnar representation, vectors in memory, a lot more performant to execute instruction. And I highly recommend reading this seminal paper to understand better about it. So what we did is we started with, okay, let's find a group of people who care about this and bootstrap the project. What would the spec look like? And it happened that the Apache Drill project actually already had in-memory columnar representation that looked exactly like what people wanted. So we started from bootstrapping the project with that and spinning off the in-memory columnar representation from the Drill project into its own project that became Arrow, and that focused on this fast query execution. So even if it's also a columnar representation, it optimizes for very different things than Parquet. Parquet focuses on fast disk retrieval and projection, predicate, pushdown, and at-rest compression, when Arrow is focusing on vectorized execution, zero copy transfer, and fast in-memory processing for the query engine. So that's kind of the initial requirement. And then you see, so this timeline starts right immediately after the end of my previous timeline in 2015, right? So Parquet graduated, and then there was a kickoff on the requirement on the Arrow project. It directly became a top-level project out of Apache Drill. And then a lot of collaboration happened as well. Like Arrow was in pandas, right? The Parquet C++ implementation is tightly integrated with the Arrow C++ integration. They just work together. It's basically the same library to get very quick pandas, integration in Spark, and nowadays, now also all major warehouses support Arrow as a fast interchange in between of result sets. You have things like DuckDB that make it very popular to have vectorized execution on your machine. And it's interesting to see the full circle, right? We started from these big databases that we do on one machine things. We moved to distributed databases to scale that up. And now we're back to a single machine, very high parallelism, and do processing really fast on the really parallel machines with fast in-memory processing. So lesson learned from this part. So I talk about this, snowball effect, but really, when you have an exponential curve, at the beginning, it looks really, really flat, right? At the beginning, the ecosystem grows very slowly, and then suddenly, there's an inflection point in it accelerate. Sorry. And thank you for the water bottle. And then, what you can do at the beginning is really bootstrap with the bigger community, right? Reach out, leverage the fact that there were a lot of open source project companies connected together around the development of Parquet to bootstrap Arrow with the bigger community. And for Parquet, we can stumble onto it with having 2 contributors with Twitter and Cloudera at the beginning, and then slowly growing, getting Netflix and Criteo and the Spark people to use it and grow around it. But for Arrow, it was more like thinking about, okay, like we need this collaboration early on, and how do we make it happen faster? And through that, you can find like-minded people, right, who will drive the vision with you, right? You don't need to convince everyone that this is a good idea. You just need to convince a few of them, and you convince a few visionaries, right, that will see the vision, see why it makes sense, help drive toward this. They will convince early adopters, and the early adopters will convince the other people, right? So there's kind of a scalability aspect to this, because it's always, feel like boiling the ocean, but there's really like a network effect that happens, and that really enables this growth. And it's, and it's all about the connection we built along the way, right? So I'm describing that like as if there's an evil plan. This is how we're going to take over the world. But actually, it works because we enjoy the process, right? Like someone was telling me, you're doing open source the right way. And I think in their mind, they were thinking the hard way, where you collaborate with a lot of people and you need to get people together. I'm cheating because I'm actually really enjoy this. I really enjoy, you get to work with amazing people that you wouldn't get to work with otherwise. And it's great to be able to build those relationships, collaborate in open source. Nobody has to be there. They're doing it because they want to. And it's really a rewarding mechanism. So on the last part, moving with OpenLineage. So there's, if we think, okay, now we solve the data interchange from disk to memory and from memory to memory aspect, what's the next other big problem that exists, right? And I think there's the big data is one problem, like scaling to data, but the big data organization is the other problem. Like people depend on each other. Within each team, they know what they're doing, or usually they know what their teammates are doing and how they depend on each other. But across teams, that's where a lot of friction happens, right? Because they're consuming data and they have no idea where it's coming from. They have no idea who's consuming the data they produce. And whenever a lot of things change all the time, and that creates a lot of friction. My data is broken because someone changed the schema, I was not aware of it, and all these kind of problems. And so often when you see there's this, I've built that data hierarchy of needs, there's this Maslow's hierarchy of needs is, if you're looking for happiness of becoming the better form of yourself you can be, first, you need to solve basic needs, right? You need to be fed, you need to have shelter, you need to have security, and then once you have those things, then you can build on, being a good person and building things and having an impact on the world. So adapted to data, like before you can do anything, right? And we often scramble in all the noise of things are broken constantly. First, the data needs to be available, and then it needs to be fresh, right? It needs to be like up to date, and then it needs to be correct. And once you have all those things, then you can keep your head above water and you can start saying, oh, maybe you're working on your business optimization, reducing costs on something, or finding new opportunities, building LLMs or whatnot, and building new products. But most of the time, we have our head underwater, right? And we're constantly fighting while the data doesn't show up, or it's showing too late, or there's a bunch of nulls in the data. And it's just like, this is a lot of thrashing that prevents us from achieving higher goals. And so that's where, like moving on, at the time, so I was working at WeWork, and so, in this phase where we're seeing a lot of growth and a lot of investment and building data platform and figuring out how to do streaming, how to do batch, how to store data, how to do schemas, instrumentation, all of those things. And the one big missing piece in the ecosystem was building a map of all the data sets, all the jobs, and understanding how everything depends on each other, right? And that paved the way to solve data reliability. So then, WeWork blew up, like very publicly. And that led the way to the creation of DataKin. We figured, well, we can all go our own way, or we can push that vision of how we build data observability. It's so much more mature in the service world when people know how to talk about SLAs, they know how to do operations, and there's so much more that is being done. In the data world, it's still the Stone Age, right? It's just like, as long as everything works, it works. As soon as something's broken, it's hell on earth. No, it takes weeks to resolve, figuring out where the data problem is coming from. So that led to the creation of OpenLineage, as we need the parallel of open telemetry. We need a way to standardize how everything collects lineage or exposes lineage. Like before, and I give here the example of an ecosystem like through open source, but the same for all the proprietary data catalog as well. Like everybody reverse engineers everything. It's just very expensive, it's very brittle. Every time one of those things changes, your warehouse, Spark, anything, it breaks lineage and they need to update it and make it work. And it's just been like a giant waste of resources and repeated investment to make it happen. So if only we have a standard way to expose lineage, now everybody works against the standard. And there's a lot less duplication because instead of n square communication, it's a linear growth. Every newcomers to the ecosystem can just implement against the spec instead of agreeing with everybody else how they exchange data. And it's also a lot more stable because everybody tests against the standard and they don't break each other because they're unaware of the dependencies they have. And so OpenLineage becomes like this common layer to exchange metadata in an asynchronous way, either through Kafka or things. And I, again, have my little timeline. So it also starts, at the end of the previous one. So we start from Marquez, this initial project that joined the LFAI&Data that was both the instrumentation and the storage and the analysis of data. We split off OpenLineage as just the spec and instrumentation because that's a common part that unifies the ecosystem together. That's the standard representation that everybody benefits from. And so that's the part of the project that's the most going to benefit from this ecosystem and growth. So, and quickly you see a lot of adoption from Microsoft, from Google recently, from Manta, from Egeria, Metaphor, Data Hub, because there's this same common need. So everybody needs this, right? So all you need is to push this product and make it happen. So going a little faster on the model, there's a core model of lineage, and then it's extensible with facets, and everybody can focus on the part of metadata. This is how you attach metadata to your lineage, whether it's data quality, whether it's the version of the code, whether it's the version of the schema, and tracking those changes. So on dataset, you can track stats like how many rows, quartiles, how the schema changes. On job, you can check how the code changed, how the query plan changed. On runs, you can check, how long it took, how did the query profile change, what were parameters, hyperparameters that were passed. And you can extend that. So just going a little faster on this path so that I can talk about my conclusion. And this is just an example on how you would do that in Python. There's also a Java client on how to emit OpenLineage. And you will find resources on the OpenLineage.io website, the ecosystem, how to implement this, how to leverage existing integrations. There's lots of work already done with Spark, Airflow, Flink, DBT, SQL, all of this. And the possibilities are endless, right? Lineage is not a feature. Lineage is a means to an end. People need lineage for data reliability. They want lineage for their machine learning reliability, for compliance with GDPR, CCPA, banking regulation, BCBA 239. They need for governance. They need to know, are we computing our dashboards based on the correct data? There's so many things you do with lineage, and everybody needs that. So it's high time we standardize it. And, it's not like you build, when I talk about, people are telling me, I was talking about OpenLineage and saying, oh, I've done this before, and, we're following the playbook from Arrow. It's like, what makes you think you can do it again? It's just like, oh, good point, right? Like, so Parquet, it kind of just happened. The project was successful. I didn't know what I was doing. But really, the trick is, we're not just like having an open source project and doing mind tricks so that everybody adopts it. The initial thing is, what does everybody need? So whether it was Parquet, for Arrow, for OpenLineage, there's an unmet need, right? And you know that from inside for trying to build those data platforms and like being in the middle of it and seeing what's missing. And like, okay, everybody needs that, and it's not happening because engineers don't like to talk to each other, right? It's just like we're kind of nerds and we like reverse engineering stuff. And it's actually a people problem, right? So if you create the project that everybody wants, you empower the community to become owners in this, and you put degrees in the project, then you get success. So it's just the trick is to start with what people need, and it makes things easier. And if you know the stone soup fable, and this story, this is children's book. Someone comes to a village in the town square, and they start heating a pot, right? And people come to see them. Is like, what are you doing? Well, I'm making a stone soup, meaning they have hot water, they put a stone at the bottom, making a stone soup, and of course the stone doesn't add any flavor to the soup, right? It's just neutral. And so they're just a soup at nothing, and they say, but you can bring your own ingredient and make my soup better, and we'll share the soup, and it's for everyone. And so people come with leek, and they come with carrots and potatoes or whatnot. And just the actual making into soup. So that's all I'm doing. All I've been doing has been stirring the pot, encouraging people to join and participate and become owners in this and making it happen. And there's lots of magic that happens when you just provide the focal point for making it happen, right? And it's just about aligning incentives, understanding everybody's incentive, align them, create this network effect, and the magic happens not when I convince people, hey, you should join in, but then when people start talking to each other, right? The magic happens is just like, oh yeah, we're all trying to do this, it makes sense, and then everybody gets convinced by the group more than just me talking around and convincing. And so yeah, lesson learned, every contributor is a stakeholder, there's a snowball effect, open source communal shapes and sides. You can bootstrap the community and like create this bigger group at the beginning to bootstrap this. Collaborate with innovator trailblazers, and it's about the journey, not the destination. Finding what everybody needs, feels a need, and align incentive, and magic happens. Thank you.